Welcome to my exciting adventure through building a game engine called Midpoint. This project is driven by a desire to share working knowledge with others and bring real value to the world. So what makes this game engine different? First, the UI UX is modern and clean. Second, it's AI first, integrating AI directly into the engine. Third, it's open world first by making massive maps easy. In this video, we will be covering the setup for our Tauri/U project, Midpoint. I highly recommend finding the official Tauri U template and starting from there. It will include bindings and examples for you. I also recommend exploring the live repo for this game engine by visiting my GitHub. That way you can fill any gaps from the videos and test working code. Okay, let's get started. As you can see, I have built out an initial architecture for our U application, which lives within our Tauri application. There is a spot for all of our functional components, which render UI to the screen. There is a spot for our contexts, which help us share data between components. There's also a spot for our GraphQL calls. Feel free to switch this out with REST calls as you see fit, as I will not be covering the server-side API portion in these videos. Lastly, there is a spot for our renderer, which will form all of our logic necessary to render our scenes. Now, we can take a look at the cargo.toml file for our dependencies. As you can see, there are plenty. However, this is the nature of Rust development. As we continue, we specify some more dependencies with special options, along with other configuration options. Make sure that you have matching versions for these various packages, as even a minor mismatch can result in breaking changes. I also wanted to share quickly the gulp file, in case you wanted to compile Sass to CSS in your setup. I think it has many advantages for styling, although I won't be sharing my styles in these videos. Now we're ready for the app.rs file. Here's how we get it started with our use statements. We're primarily interested in U and some other components that have already been created. I will show you those soon. Here we begin by defining the reusable invoke function, which allows us to call functions in the Tauri background process. In turn, we will have access to the local file system and other non-WASM functionality. We also define the app component itself. As you can see, there are two primary contexts used in our app, which are set up here. The local context is meant for the current session state, such as which page the user is viewing. The saved context is for saved file state, such as which textures have been added. Besides setting up these contexts, we also set up the main scaffolding for the engine. The token loader and project socket are purely functional, in the sense that they do not render UI, but are still best used as components. We will cover them as well as ViewNav, so you have a sense for how it will all work. I will not cover the primary view, as it doesn't carry any unique lessons. If you want the code for the primary view, you can find it on GitHub. Here you can see the components.rs file, where we specify all of the public modules, components in this case. This is important for importing components into others. Now we can take a look at the project socket component. This will be the primary way where we interact with WebSockets. WebSockets are necessary for real-time bidirectional communication this engine demands. Here you can see how we define some everyday structs and how we will typically include our context in the component. We also open some empty state to hold the WebSocket connection. Now take a look at the join group function. We have some console logs and clones as needed, but the primary functionality is near the bottom. Engine users will create projects, so we will be joining WebSocket groups based on the project ID. This will enable group-wide messages. Here we have a simple use effect, which detects when the current project changes. It establishes the connection with the server. Next, inside the use effect, we define the callback for receiving a message. Since we only expect one for now, we have hard-coded that message, which is refresh context. This will allow us to simply refresh the saved context whenever the project gets updated. This is useful for collaboration, yes, but also for processing files with AI. Now, to finish up the use effect, as well as the component itself, we simply enjoy some Rust verbosity. Basically, we are setting two callbacks as well as the WebSocket state. Next comes the token loader component. This is essentially how we will pull in our authorization token, which we will use with the server API. Since we will log in through a separate Tauri app, we will pull that token from file. We get started with typically used statements and structs. Then comes the basic logic. We simply use invoke from earlier to interface with the Tauri background process, pulling in the token and storing it in the local context. Next, you can see the background process handler. Simply uses the app data directory path and searches in folder where we expect our token to be. We won't log in via Midpoint, rather doing that through a separate file manager Tauri app, which we will build in a later video. You can also see how we set up our Tauri builder and handlers. Most of these handlers will be used in upcoming videos. Now let's get back to the U side. This is the local context file. As you can see, we specify only the data needed for the session variables. The route, token, current project, and selected project are all obviously not stored in file, thus be synced to all collaborators. The projects are also stored conveniently here. We define some actions and an initial state for the context here. This can be done predictably based on which functions you expect to be needed. Here we actually write out the logic for our actions, which all generally just set the path variable to the state. Pretty simple. Now we have the saved context. This gets a bit deeper as there's more data being stored here. The file represents actual files from models to textures as well as the actual system path in addition to their cloud-based URL. This is all critical not just to collaboration, but to the AI integrations which require cloud-hosted files. Meanwhile, our engine requires local files. I will not go into detail on the landscapes yet. Components inside our engine, not the code, are actually instances of files/assets which have been added to the scene. The levels provide a simple surface for the components. It's all brought together in the saved state, which includes all the other project data besides level data. Once again, we prepare our actions in default state. It's a bit more involved this time to update the state, but it is conveniently wrapped up into these functions. Take your time to examine this code and understand its current way of functioning. Finally, to wrap up this initial project setup video, we can cover the view nav component. It's relatively straightforward. We begin by importing a button component called MD_button and specifying a nav option struct. Here we specify all of the navigation options we want to show in the sidebar. Since our engine is focused on UX, we will have a large overview map, a quest tree, and other straightforward systems for creators. If they are not logged in, let's just show a placeholder button which goes nowhere. It adds some flair to the empty page. Now, to finish this component, just iterate over the nav options and display them. I hope you have enjoyed this setup for my game engine written with Tauri, U, and wgpu. As you can see, no wgpu yet, but it is coming soon enough. If you learned anything or want to keep up with newer videos, be sure to subscribe.